All right, let's get going. For the next 45, 50 minutes, we're going to talk about KEDA. And KEDA is a event-driven autoscaler, which you can run on top of any Kubernetes cluster. And with KEDA, you can do scaling of any container based on events. So an event, for example, could be an item that is being inserted into a queue, for example. Or there's also a lot of other sources that you can use, as we will see later on. And it actually does a great job at doing just this. It's a very single purpose thing, this KEDA. Its pure goal is to make autoscaling extremely simple, and it does that very well, as we will see later on, as it's very easy to get started. So they also have these built-in scalars, and a scalar is a component, a module that can read an event source for you, let's say a queue or something else, and based on the metrics it gets from the particular queue, you can do scaling. So if you would add 1,000 items to a queue, KEDA would see that, and KEDA could scale any container you like based on the number of events in that particular queue. So before we dive in, my name is Erwin Staal. I'm an Azure architect and DevOps consultant. I live in the Netherlands in a beautiful place called Assen, which you might know from the fact that we were supposed to have a Formula One race here in the Netherlands this year. It's been postponed till next year. But there's been a lot of debate if that Formula One race should have been held in Assen or in Zandvoort. And unfortunately, we lost and Zandvoort got the race, but that's probably the only thing you might know Assen for. So I'm a consultant, work for a company called 4.net, and I help customers do things on Azure and work in a DevOps manner and practices. Currently work for a company, Nucleus, which is based in Amsterdam. So before we dive into KEDA, let's dive into containers and Kubernetes for a moment. We'll just spend 5 minutes here to make sure everyone who hasn't been doing anything with containers yet or with Kubernetes still has enough context to understand where KEDA fits in and what problem KEDA solves for us. So these containers are these lightweight standalone executable packages that contain every bit and byte that your application needs to run. So it contains your application itself, of course, but it also contains every framework and all of the settings, etc., what your application might need to get running. So instead of having to install frameworks on a virtual machine to run your application and potentially have multiple versions of it, etc., you don't need it anymore. You just have to install a Docker runtime, and then your container, any container basically, can run. So there's a lot of benefits to do that. But just running one container is not that useful. Especially in production environments, you want to have multiple containers on multiple machines because you want to be high available and you want to be resilient to failure. You want to be sure that you can handle the load that you need to handle on your containers. So what you need here is an orchestrator, something that can manage all those containers for you and can do the scaling, etc. So that's where Kubernetes comes in. It's not the only container orchestrator out there, but it's by far the most popular one. So Kubernetes consists of two main items. It's the master and it's the workers. So the workers are responsible for running your workload. They will run your actual containers, and they will mostly run on a virtual machine, for example. But it could be bare metal as well. And the master is responsible for making sure that what you want it to run, it actually gets run. So if you tell it to run a particular application, the master is responsible for making sure that that will happen and to install it on any of the workers. And it's also the master to who you talk to if you want to deploy an application. And it kind of works like this. You write an application.yaml, or actually you write a YAML file, and that specifies how you want your application to run. So yeah, you have to do a bit of YAML here, but it's not that hard actually. So this is a very small example of it. I'm not even sure if it will run. It probably misses a few details, but it gives you an idea of what it could look like. So the one over here is going to deploy a container called Grafana, which is some dashboarding tool that's very popular in the open source space. So we specify a few things here, like the container port, so the port we want to run the thing on. And we also specify the number of replicas, which represents the number of containers, the instances we want to have run to be high available and to be able to handle the scale we need to handle. So we give this file to the master, to the API, and the master will make sure that what we've specified here, that will end up on the cluster. And this is a desired state deployment, which means that the master will be continuously looking if the stuff we've been writing down in this file is still the state as it is on the cluster. And if it's not, it will try to fix that. So first it will start to run one of the 3 replicas on each of the workers, so that we have high availability, etc. But if one of the workers goes down because someone did unplug the power cable or the network cable, for example, then there will be the master who sees that we no longer are in the desired state we want to be in. So the master is going to try to move the replica that was running on that worker to another worker to make sure we still have that state that we described in the file. So that's Docker and Kubernetes in 5 minutes, and that should be kind enough to get the rest of this talk. So let's talk a bit about scaling here. Basically, there's 2 ways in which you can do scaling. One is horizontal and the other one is vertical. So by horizontal, we mean that if we need to do scaling, we simply add more of the same machines, for example. So we just add 1, 2, 3 extra virtual machines to make sure we can handle additional load. Vertical scaling means that we are going to scale the machines we already have. So we, for example, add more memory, or we add more compute power, more CPU, for example. More disks could also be an option. So basically, there's 2 ways of scaling. And scaling in Kubernetes then looks kind of like this. These are the options you kind of have by default. So there's horizontal scaling. So we can scale the number of nodes, the number of VMs, and we can also scale the number of pods. So if your API needs to handle a bigger load, you could just increase either one of them. You could also do a vertical scaling, which means that we could change the size of the nodes, and we could also change the size of a pod. We can limit a pod in the amount of compute resources it's allowed to use. So we could also increase that. But it could have downsides for other stuff that's also running on the cluster, obviously. So these are the things you have in Kubernetes, and kind of only the horizontal scaling is there general available. It's not beta anymore. The vertical one is still in beta. So you have to do some additional things to get vertical scaling working, especially if you want to do it on Azure, for example. But there's one problem with the scaling that's default in Kubernetes, and that's that it only can react to the symptom. It cannot react to the actual cause, because scaling in Kubernetes is mainly done based on either memory usage of your cluster or CPU usage of the cluster. Whereas again, CPU usage is the only one that's actually not in alpha or beta state anymore. So the other ones are. So, and by that means that if you only can react on CPU, you're already kind of too late. Your cluster was already doing a lot of work, and it would be nice if you could be ahead of it. That is where KEDA comes in. KEDA gives you the ability to do just that. Scale your cluster based on events instead of just the CPU, etc. So you can install KEDA on any cluster you like. It can be in the cloud, it can be on your local development machine. So it could be in Azure, it could be in Google, Amazon, it doesn't really matter. It can run anywhere. It just needs a basic Kubernetes cluster. So it makes use of these extensible and pluggable scalars to grab the metrics from any event source you could have. So there's a number of built-in scalars. We will look at a list later, but you could also write your own. Since KEDA is open source, you can find it on GitHub, and you could just add your own scalar or modify an existing one if it doesn't exactly do what you need it to do. So those scalars grab the metrics from your event source, which could be a queue, for example, or anything else, and feed that metric into KEDA and Kubernetes to allow the scaling. And that allows you to do proactively scaling of any container I know this talk is called something like with Azure Functions, and it can scale Azure Functions in a container, but it could be any container. It doesn't matter. It could run any programming language you like. Doesn't matter. You could even put a directly in a container if you like and scale it. That doesn't really matter. So it feeds that data it grabs from these scalars into the Kubernetes APIs, and it's Kubernetes itself eventually that does the actual scaling. KEDA just provides it with metrics and makes the scaling work for you. And that's a good thing because that makes KEDA pretty small. It just does one thing and does that very well, and just leverages the Kubernetes APIs wherever it can. One thing Kubernetes cannot do by itself is allow containers to scale to and from zero. So you always have one instance of your container running, one pod running in Kubernetes all the time. With KEDA, we can actually scale down to zero, which could save some of the compute resources we have. And one of the things KEDA does differently compared to its competitors is that it allows the consumption of the event, allows the consumption of whatever is in your event source up to you. And that's a big difference compared to others. We will dive into that a bit more to make sure that's clear to you and you get what the differences are. Before we go there, let's have a bit of a graphical look at what KEDA actually consists of. As you can see, there's a metrics adapter here, there's a controller, and there's a scalar. So the metrics adapter makes sure that Kubernetes can get the metrics from KEDA that can be sent out there. And it then just uses the horizontal pod autoscaler that's already by default in Kubernetes to drive the actual scaling. So it just uses what's already there. And we've already talked about the scalars there. The scalars are the things that call out to your event source, the queue, for example, as we will see in a demo later on. It will call out to your event source and see if there's anything on there that it needs to scale based on. And you also see in this diagram that it's actually KEDA and the controller there who does the scaling from and to zero, whereas it is the horizontal pod autoscaler who does the scaling to and from one. So KEDA just does a very small portion there because Kubernetes itself can't do that. So here's the list of all the scalars that are currently built into KEDA. As you see, there's a few for AWS, there's a few for Azure, there's one or two for Google, and there's also quite a few for open source things out there, like the Prometheus one, for example, which we'll also look in one of the demos later on. And new ones get added all the time. So I just yesterday added the one for cron, which is on the bottom. That's not even publicly available yet, if I'm correct. It will be in the next version. But someone in the community decided he needed to be able to have KEDA scaling on cron. So he just added it, and it got merged in the source last week or a week before that. So you can actually write it yourself and have it be in there. So let's talk a little bit about what I meant with that KEDA allows you as the owner of the application to do the actual grabbing of the event from your event source. So this is how KEDA basically works and how it talks to a queue in this particular example. So KEDA in step one will monitor your queue. It will ask your queue every once in a while how many items there are on it. And based on the number of items it retrieves, it will go and scale your application. So it will tell Kubernetes that it needs to scale out your container, your app. But it's then your application that needs to go to the queue and fetch the actual item. KEDA doesn't do that for you. KEDA just tells you your app needs to scale. And then your app itself needs to go to the queue and actually grab an item and do the work. So if you look at a few of the alternatives that are out there, then you often see a different flow, which kind of looks like the one I've tried to draw here. So the first step is that, again, they go to the queue to see how many items are there and if there actually are any items there. But what they do is they actually grab the item from the queue and give it to your app over an HTTP connection. So the only thing your app needs to understand and needs to listen on a simple HTTP request, for example. So it's up to the alternative implementation here to read the actual queue and grab an item and give it to your app. So that makes your app very simple. You don't have to worry about working with the SDKs that come with this particular queue. And SDKs sometimes can be quite hard. So it's actually it's a nice approach. It's easy to get started with, since you only need to know HTTP to work with the system. But it also has a few downsides in that you also cannot use the benefits of the actual queue. So if, for example, in the alternative approach, your app is unable to process the message, how is it going to give the message back to the queue? There's no connection there between your app and the queue. So you have to figure that out yourself. Whereas if you would be in the KEDA world, you would just grab the message from the queue. So you would work with the SDK that comes with that particular queue. So if anything goes wrong, for example, you could just make it visible again on the queue or put it back in that same queue, for example. So it's a bit harder, since you need to work with the SDK, and if you have multiple event sources, you have multiple of them, and there might even be different vendors there. So there's downsides to it, but there's also pluses there. All right, time to see something in action here. So the first demo I have for you, I'll be running on AKS and a combination of AKS and the virtual nodes in Azure. We will also see later on a demo on some local Kubernetes cluster I have on my laptop. So the first one will run on Azure and AKS, the virtual nodes. And that's pretty cool because most of the time you will probably be using events in some batching way. Like, for example, the customer I currently work for, our customers send us data once every while. So that could be, for example, 1,000 items at a time, and then 2 or 3 days, nothing. And then again, 1,000 items at a time. So if you would run all of those events on just our AKS, just our Kubernetes cluster, we would have to scale it out for that additional load all the time and then scale it back in. And it could actually have implications for whatever was running on that Kubernetes cluster already. It might have performance implications there because scaling takes some time. What you can actually do in AKS is leverage the Azure Container Instances there as well. So what you can do is specify in your YAML file that you don't really care where your pod gets to run, and AKS decides then where it has to go. Is it something that you're going to run permanently? That will probably end up on the Kubernetes service. If it's going to be something we do with KEDA, so some short-lived thing, it will probably put in Azure Container Instances so that it doesn't have to run on your own AKS cluster. And the nice thing is that for you as a developer or the one who publishes the app, you don't see the difference in the connection or whatever. You just have one kubectl and one API you talk to, and based on the data you put in your YAML file, the AKS cluster is able to decide where to actually run your pod. So that's pretty cool, especially if you're doing event stuff like we do. All right, so let's dive into the first demo here. What we're going to see in the first demo is I'm going to show you how easy it is to actually get started with KEDA. How to create a new function and get it run on the cluster and get it scaled based on events there. So the first demo I'm going to do is I'm going to create an Azure function. We're going to put that into a container, and we're going to run that on AKS using KEDA. So to create a new function, we use the Azure Functions CLI. So I can say func, and I do an init in the current folder, and I specify that I'm going to use the Docker one. So you can also obviously run Azure Functions on Azure, and you wouldn't necessarily need a Docker container there. But we do here, since we're going to use it on Kubernetes and have it scaled using KEDA. So now it's been writing a few files here for me, and it's been initialized as a Docker file. So next step is to do a func new, by which we specify that we want to create a new function. All right, so we're going to choose option 1 here. Since I want to run this function, I want to have it triggered by the queue. We're going to use a queue trigger here. So I can specify a name here, so I will. And it's now going to do some scaffolding and make sure that my Azure function is going to be built, and it will by default be triggered on a queue. So let's open Visual Studio Code, and let's have a quick look at what that actually looks like. All right, so there's a few files here that we could have a quick look at. I will do a quick zooming here so it's kind of readable for everyone. All right, so for those who have never seen an Azure function before, this is a very, very simple, small example. And this is basically it when it comes to a coding perspective. So you have a run method, and the first thing that is specified in the run method is the binding we're going to use. So here's that queue trigger again. And what this queue trigger is going to do is it's going to monitor the queue for me, and it's going to monitor this particular queue. And if there's any item on that queue, this run function will be called, and the result, the item on the queue, will be in the myQueueItem parameter. So we just talked about how in the KEDA world you have to deal with the SDK yourself. But if you actually use an Azure function here, you don't have to. The Azure function takes care of the SDK and the connection with the queue for you. So there's actually input bindings, which we've been using right now, the queue trigger. But there's also output binding. So you could also go back into the queue, for example, if you need to. There's obviously also a Docker file because we're going to run this thing on Docker. So it's a .NET Core one, and as you can see down here, it's using the Azure Functions image by Microsoft, and it's the 3.0 version here. So there's now two more things you need to do to get this running. We need to specify the connection string to the queue we're actually using. So you probably don't want to see me typing all the time. So I'm just gonna grab a working example here to just show you what that means. So the only thing you have to do is here in that same run function again, specify the name of your connection string. It obviously needs to know to which queue it needs to connect. So you specify the name, and then in the local settings file, you specify the actual connection string. And that's kind of it. You could now go func run on your terminal, on your command line, and this function would actually run locally on your machine. That's all there is to it. You can debug it, etc. It's a very nice developer experience right there. It's not much harder than this. So, but we actually want to run it on the Kubernetes cluster. So how do we get this working example deployed? We do that again by the function Azure CLI, but this time we say func Kubernetes deploy, and we then give it a name. So it's gonna be hello KEDA, and you have to specify the registry you're going to push this container to. So in my case, that would be my Erwin Staal Docker registry, because what this Kubernetes deploy command will do, it will build my container, it will push this container into my registry, and it will then tell Kubernetes that it needs to fetch that image and actually start running that thing. And it will deploy some KEDA stuff as well. So this would just work. If I would not hit enter, this would be deployed. But most of the time, you actually want a bit of more control over what's actually happening here and what's actually being deployed for you. So what you can do is you can specify the dry run switch, and that won't actually run it anymore, but it will output what it would have done for you. So what you could do, for example, is this. You could say do a dry run and put the output of that into a deploy.yaml. So what that gives you is this is a YAML file that looks like this one. So for those of you who've ever done anything with Kubernetes, it looks pretty familiar to you. This one is the secret. And this is actually the connection string to a hashed version of the connection string to the queue, and that's being put in a secret. There's a deployment, which specifies which container to be run and things like that. We also saw this in that very small example in the beginning of the talk. But actually, an interesting thing that's new because of the fact we're going to use KEDA is this kind skilled object. That's a KEDA thing. And this specifies some of the properties for you on how you want to run this particular Azure function in, or this particular container actually on KEDA. So one of the interesting things here is the trigger down here. We said when we created the Azure function that we wanted to have a trigger based on the queue. So we specify the type queueTrigger here. It also needs to know the name of the connection we're going to use. So this is actually the name of the secret that was been specified on top of here. So it will fetch that secret for us and use that connection string. And you also specify the queue name and the name of the item you want to have in. So it will then start monitoring that particular queue for you. And then there's a few additional settings that allow you to make the running of this particular container a bit more specific to your needs. So, for example, there's the polling interval, which specifies in how much seconds KEDA will try to read your queue again. So in this example, it will go to my queue every 5 seconds to see if there's anything new, or actually figure out how many items there are on my queue. The cooldown period specifies how long it will wait after your queue is empty or your threshold isn't been met anymore. How many seconds should it wait before it starts scaling down again? So the default here is 5 minutes, but I've specified 5 seconds. So in the demo, we can quickly see it scale up and scale down again as well. And here we can specify the minimum and the maximum replica count. So as I told you, KEDA allows you to scale back to 0. So that's what's specified here. But luckily, you can also specify the maximum replica count you want to scale up to. So you could imagine that if your application, your function that you're going to run here, if that needs to connect into a SQL database, for example, and if you let your container just scale up to 1,000 instances, you're probably going to hit the limits of that SQL database. So this setting allows you to set a limit to that, to make sure that the stuff you're dependent upon doesn't get overflooded with your request, for example. All right, so let's see here if that actually does work. Let's go back to the terminal. I have already deployed this application, so we don't have to do it anymore. It sometimes takes a bit of time to build a container and push it and whatever. So let's not get into that. Let's have a quick look at the actual cluster we're looking at. As you can see, this is the only virtual machine I now have in my AKS cluster on Azure. So I have a cluster with just one virtual machine, which is nice for testing. And you also see the virtual node down here. You just see that as a node, as if it was part of your cluster. So that's pretty cool. That allows you to just run every kubectl command against the cluster, and it will allow you to go either way, to AKS or to the container instances. So that's pretty cool. All right, so let's do a kubectl get pods. And what we then see is that there's no pod running in my namespace. And we were kind of expecting that, since we told the deployment here to scale down to 0. So there's nothing there. If we do a kubectl get deployment, however, you will see there is a deployment. It's the hello KEDA queue. And you'll see that there's 0 out of 0 ready, which is exactly what we want. If we then look at the definition of the Kubernetes horizontal pod autoscaler, we will see that there is one. KEDA created a definition for us. And what you see here is that the minimum pods here does say 1. That's because Kubernetes by itself can't scale to 0. So it also won't show you that. It took me quite some time when I started with KEDA to figure that out. I thought something was wrong all the time till I looked at the actual deployment and saw that there actually were 0 pods running. And it is just the horizontal pod autoscaler that can't tell you that. But that is what's actually going on here. All right, so let's see if that scaling actually works. So what we're going to do here is let's have another look at the deployment. And a watch there. So it will now continue to watch the deployment so that we can actually see it scaling. So what I did here is a demo. I also created a, let's see where it is. There it is. I created a very small demo application which does nothing more than put 100 items on that queue that my Azure Function and KEDA are connected to. So if I run this application, let's do that. That should add 100 items to the queue, and it's actually already done. And as you can see here on the left, KEDA already picked it up and already started scaling my my container there. So the function itself actually doesn't do that much. It just prints out the item on the queue. It waits 10 seconds, otherwise it will be way too fast. And then it's just done again, and it will be will have handled that particular message. So as you can see, KEDA starts scaling that particular deployment, and it will go up to around the 16 or 20 till my queue actually is done. So while that's going, let's have a look in AKS here. And sometimes this portal isn't that quick, so it might not work this time. But if we have a look at the nodes here, then you can see that it indeed started adding one container here to the virtual node, and there are already 17 on AKS, and that's the default. That's the default containers running there. So maybe if I hit a refresh a few times, and if it's quick enough today, you will actually see that all the containers that have been started over here actually end up on my virtual node and not on my AKS cluster, because it's doing a balancing thing there. And I also told it in my YAML file that I would like it to go to the virtual node instead of to my default AKS cluster. So as you can see over here, my queue is already empty, so it started scaling down again. It didn't even make it up to the 20. The 5 instances that were available were enough to get that queue empty, and it started scaling down this particular deployment. And as you can see, it actually started deploying almost all of those pods on the virtual node. One did got added on AKS here, so it does that by itself. But there was little to none impact on my normal cluster, so my normal API, etc. Almost all of them were run on the virtual node here. All right, so that was a quick example of how to create an Azure function and have that run on KEDA, and it only took us like 20 minutes. So it's quite easy to get started with KEDA and with actually running anything on your cluster. So with that, let's move on to the second demo I have. Because I told you in the beginning that you can actually run KEDA on any Kubernetes cluster. So this one was running in Azure. The next one I'm going to show you is running on my local machine. So I'm using K3S and K3D to actually do that. And sorry, K3S is a smaller implementation of the full-blown Kubernetes. What they did here, it's a product by Rancher. What they did is they took out all of the parts that you don't really need, so that a lot of the alpha and beta stuff have been get written out of Kubernetes and do not exist in K3S. And also they replaced some of the default stuff there with versions, other products that are a bit more designed to run in a low power, low compute resource environment. So there's Traffic, for example, instead of Nginx. There's SQLite there instead of the default etcd, for example. All lighter versions of what's there by default, and that makes the K3S only takes you 40 megabytes to have a running Kubernetes virtual instance. So that's pretty cool. Allows you to run Kubernetes on Raspberry Pis, for example, or on edge devices, or on your local developer machine. And what you could do to actually do that is use a tool called K3D. And K3D lets you manage clusters, Kubernetes clusters, on your local machine. And it does that by spinning up one or multiple K3s containers and run Kubernetes that way. So pretty cool tooling, all open source, and allows you to run a full Kubernetes cluster on your local development machine. So the second demo I have for you is the one on using the Prometheus scaler. So I told you there's multiple scalars, and it's not just an Azure thing or Microsoft thing, this whole KEDA thing. Prometheus actually is a time series open source database. It's used a lot in the open source world to store metrics data, store event data, etc., time series, real-time data, things like that. It's often used in combination with Grafana, whereas the Prometheus is your database, and Grafana is then the application you use to visualize the data, so the dashboarding, etc. So what I did here, I wrote myself a small ASP.NET Core application, used the web API, and I added a metrics endpoint that Prometheus can read. So Prometheus scrapes the metrics from my app. So there's metrics like how many requests have there been done and how long did those requests take. So Prometheus scrapes those metrics, put it into its database. Then KEDA can read those metrics from that Prometheus database. And based on that outcome, based on those metrics, it can decide that it needs to scale your application. So you can put in Prometheus whatever you like, whatever metric you like, and you can then have KEDA scale based on whatever that metric might be. So let's have a quick look at what that looks like. Let's go into this one. So it's not that much different from the example we just looked at. I wrote a very small API that exposes the metrics on a endpoint. And then you have to, again, write one of those scaled objects to make it known to KEDA and have KEDA scale it. So this one looks quite similar to the one we already saw. So down here, it's not a queue trigger anymore, but this time it's a Prometheus trigger. So it also has a few different parameters here. It obviously needs to know where your instance lives. It wants to know the metric name you want to look at. It needs a threshold. So if the metric goes over the threshold, it will do scaling. And you can specify a query. So this is the query that KEDA will run against your Prometheus database. And that query will then return you a particular value, and KEDA will do scaling based on it. That's all there is to it, really. So let's have a look at Prometheus then. This is Prometheus, and it's a very simple UI. Its strength, its power is under the hood, obviously. So let me paste that particular query into there, so you can actually see it working. Go to the graph, do an execute. So as you can see, there's nothing here because there's nothing, my application is not being called here. This is actually the metrics endpoint of that application. As you can see, it is the /metrics one. And these are the metrics that are exposed by my application, and Prometheus scrapes those metrics every once in a while and puts it into its database. So let's make sure that we, let's see how that works when we give that API of mine actually some work, and let's see if the scaling there actually does anything. So what we can do here, well, let's first have a quick look at that K3D tool I told you about. You can do, for example, K3D list, and it will show you all the Kubernetes clusters you have running on your local machine. And as you can see, I have 3 of them, and there's just one running. And you can actually have more of them running if you use different ports. That's fine. So you could even have multiple Kubernetes clusters running on one developer machine, which is pretty cool. So let's have a look at the deployments here to see what's actually running on my cluster. And there's 2. So this one is the actual Prometheus application which is running, and the other one here is my .NET Core application that should scale based on the number of calls that we do to the API. So let's see if that actually works. Let's have them side by side here for a moment. Let's see if this one still responds before we start doing anything. This one seems to be quite fine. Then, yep, we also see that metric going into Prometheus right away. So let's make sure we have a bit of traffic there. So to generate some traffic here, I use a tool called Hey. It's written in Go, and it allows you to call a certain URL and do some load testing with that, for example. So I'm gonna have that run. It will do 40 concurrent requests for the next 30 seconds. And it shouldn't take too long before KEDA sees that and starts scaling your application based on the metric. So if we start looking at this one, at the graph over here, then we can also see that there's requests coming in, and it's going up, it's going up, it's going up. And KEDA continually starts reading the metrics there, or every 5 seconds really, because that's what I've specified here. And it will scale your application based on that particular metric. So after half a minute, that Hey tool will stop spamming my API, and it will go down again. The metric will go lower, and KEDA will see that, and it will actually start scaling down this particular app as well. So that's another example of what you can do with KEDA and another type of scaler here. This one's pretty awesome because whatever metric you put into Prometheus, that doesn't really matter. You can scale any container based on that. So a lot of possibilities using those two there. All right, it will take a while before it scales down, so we're not going to wait for that. We're going to have a look at my last final demo. Let me go to that particular code. And the one is over here. All right, so one of the things that Kubernetes does for you is that it does automatic scaling based on CPU and memory, etc. What that means is that Kubernetes is an AKS, for example, will start to scale your cluster based on the load. So you could have this situation where you have 4 instances, 4 virtual machines, for example. And if there isn't that much work anymore, then AKS could decide that you could do with 1 less, and it would just kill off one of those virtual machines. But what if you were running a long-running job, long-running task on Kubernetes? Say you were doing some batch processing, some image recognition, which could take over hours, for example. So that could mean that if AKS decides that it needs to scale your cluster, it would simply remove that machine from its pool, and whatever is running on it gets killed. And so your long-running process, which could almost be done, will get killed and will get removed from the cluster. It will probably restart because there's probably a queue item or whatever that get it restarted again. But it's a waste of time. It has been running for so long and would have almost been finished if it weren't for Kubernetes to kill it. Luckily, there is a way in Kubernetes to fix that, and that's with a job. If you specify a job and deploy it to your Kubernetes cluster, Kubernetes will actually wait for the job to finish and then restart or destroy your node. So there's ways to go around it. And what I did here, or what I did in KEDA, is that a job is also one of the options you have. So you could also be scaling a job in Kubernetes. So if you have these long-running things that should scale based on an event. So for example, you put 1,000 items on the queue, and those 1,000 items should trigger a job, which is then longer running. You can do that with KEDA as well. So what I've done in this example is that I've added a simple .NET Core console application. So it's not an API or whatever, it's just a console application that normally, for example, would result in a .exe And I'm using that on the Kubernetes cluster to run a particular job. So that could have been anything else. You could pick any language you like. Doesn't really matter. I'm a Microsoft guy. I'm a .NET guy. So I decided to go for .NET Core once again. So what I did here is I created a very simple console application that once again goes to a queue in Azure, fetches an item there, reads the message, writes it down, and then deletes the message from the queue. Nothing more really. So it's a very simple example of a job here. Here is the specification of the job in my YAML file, which will get deployed to Kubernetes. Again, there's a secret because it needs to know to which queue to go. And then again, there's a scaled object, which looks a bit different this time to compared to the two we already saw earlier. And so there's a scale type is job. There's again a few settings here. You have a few extra settings here because it's a job, and you will have to tell it which particular container to start and to scale when there's an item on your particular queue. So let's have a quick look at that one as well. And so there's no job running right now. That's exactly what we want. So if we go into the Azure portal, add a message to this particular queue, it will end up in there. And as you see, it's already been picked up by KEDA, and it starts running. And it shouldn't take. It's already done actually. There was one job, and it has its completion been done. So it's already done. So that was pretty quick there. All right, so that was the last demo I wanted to show you. Here are some of my contact details. If you ever have questions after the session or whatever, you can always reach out to me. I've also have obviously LinkedIn, whatever, and there's my Twitter handle. There's also my website, my blog, where you can read stuff like what I've been presenting here today. All right. So that's it. Thank you all for listening to my talk. I hope you liked it.
Thank you, Erwin, for the speech. And we already have a question in our chat from Yuri.
Great.
Hello. If I have several Kubernetes clusters, dev, test, prod, with same named namespaces connected to one Prometheus, how KEDA can know from what cluster came metrics?
So if I got the question right, you have multiple Kubernetes clusters or one cluster with multiple?
Several Kubernetes clusters with same named namespaces connected to one Prometheus. So how KEDA can know from what cluster comes metrics?
Well, you actually specify the connection string of Prometheus in your YAML file. So that's how KEDA knows to which Prometheus instance to go. And you could actually run KEDA on your cluster multiple times if you would just deploy that into multiple namespaces there. So you could have one cluster or multiple clusters running KEDA at the same time, and it could easily connect into the same Prometheus instance. That's fine. You will probably just have to adjust your query there to make sure that it fetches the right data from that same Prometheus instance. I hope that answers the question.
Okay, thank you. And guys, please join the Zoom questions and answers if you'd like to ask more questions. And I thank you one more time for your participation on the conference today.
Thanks for having me.